All right. So, over the weekends, you read about atoms, elements, bonds, and so I want to tie that in with water. So at the top here, you read that there are four major elements that make up 96% of living matter. Those four being hydrogen, carbon, nitrogen, and oxygen. Okay. You also learned, like we went over this morning, that on the periodic table we can find the mass number, and the atomic number, which tells us about the atoms of that particular element. We also learned that the properties of elements are mainly determined by the number of electrons in their outermost shell. What we call this their valence shell. All right. So, for example, think about oxygen. So oxygen, its atomic number is 8, so it's going to have 8 protons, which corresponds to 8 electrons. The way that we indicate that is that this first shell around an atom can only hold up to 2 electrons. We indicate them with little dots. So we got 2 electrons, leaving 6 to the valence shell. We got a total of 6 in the valence shell. And the capacity of that second shell is 8. Oxygen. Less hydrogen, on the other hand, the atomic number is 1, so it actually only has 1 electron, plus 2, right there in its innermost shell. Okay. So the reason why we have to understand these electron shells is because based on how many there are, this can tell us about what molecules or chemical bonds this atom might be involved in. So we know that atoms combine to form molecules by creating chemical bonds. And they usually do this in a way that satisfies or fills their outermost shell. You might have seen the term the octet rule, right? Which simply says that an atom will bond with another atom, or favor bonding with another atom if it satisfies or completes its outermost shell. So in the case of oxygen, it needs two more to fill its valence shell. They call the octet rule. Typically,
sorry, I'm not sure about that.
I'm not talking to you, Alexa. Usually it's to fill that second valence shell with 8 electrons. Okay, so there's a couple different types of bonds that we need to be familiar with. The most common that we're going to see is called a covalent bond. I like to think of this co meaning you're sharing, valence, your valence electrons. You're sharing valence electrons between two atoms. Sharing electrons in the outer shell. And that creates a bond. And these can occur in single, double, and triple, although we'll mainly see just single and double. A single covalent bond is one pair of electrons, and a double is 2 pairs of electrons. These covalent bonds can either be polar or nonpolar. Polar just means that the electronegativities are unequal. And polar means the electronegativities are equal. All right. So an electronegativity, this is simply how strongly an atom pulls on the electrons. All right. So simple example, we have hydrogen has 1 electron in that initial shell, will bond with another hydrogen and share an electron. So in this case, both hydrogens have a full valence shell. This is a single covalent bond. They're sharing 1 pair of electrons. And because these are the same atoms, they have the same electronegativities. This is a nonpolar single covalent bond. All right. Last bit here. How is this related to water? So a water molecule H2O we describe as our oxygen, which has 6 electrons. It's going to form 2 single covalent bonds with hydrogen. So we see now both hydrogens and the oxygens have full outer shells. So oxygen has a total of 8. Hydrogen has a total of 2 in its inner ring. Now it's known that oxygen has a very, very high electronegativity. Or EN for short, has a high electronegativity. And so the electrons that it's sharing are going to be pulled more strongly towards the oxygen atom and away from the hydrogen atoms. And this creates what are known as partial positive and partial negative. This symbol right here, this indicates partial charge. I think to think about that, because if the electrons are being pulled more strongly, electrons are negative, and so the oxygen is going to be having a partial negative, and the hydrogen, because it's losing an electron, or not having an electron as close to it, is going to have a partial positive charge. We call this a polar molecule. It has a positive pole and a negative pole. You'll see this indicated sometimes like this. Right, where the bottom looks like a plus sign, that's a positive to a negative. Okay. So the reason this is important, because this affects all the way that a water molecule behaves. So for simplicity, I'm just going to draw water molecule, which we know is polar. If all of these molecules are polar, what tends to happen is that little interactions happen between the negative and the positive portions of these molecules. And so, for example, this hydrogen is going to form an interaction with the oxygen right there. Right, because negatives attract positives. I'll let you fill in all of the partial charges. And we call this a hydrogen bond. Where a positively charged hydrogen connects to an electronegative atom. This is not a covalent bond. This is a hydrogen bond just between the partial charges. All right. And this is the core of why cohesion, adhesion, surface tension, which you're going to read about tonight, all comes down to this hydrogen bond forming. So we're going to stop right there. We're going to get to the practice problem on Thursday for your warm-up. I'll talk about this a little bit more. But with that, you can go ahead and start packing up, and we'll pick up where we left off tomorrow.